Namaste students. Let us discuss about P block elements. P block elements include the elements of group 13 to 18. General electronic configuration NS2 NP1 to 6. The number of valence electron present in the P block element easy to find, that is group number minus 10. Let us discuss about group 15. Nitrogen family. The first member is nitrogen, so it is named as nitrogen family, also known as pnictogens. Means these elements can cause choking or suffocation. That's why the name pnictogens. Group 15 elements contain how many valence electron? We know valence electron is equal to group number minus 10. So here 15, group number is 15 minus 10 equal to 5 valence electron. General electronic configuration NS2 NP3. This electronic configuration is specially stable because s orbital is completely filled, p atomic orbital is half filled. Hence it is extra stable. The elements are nitrogen, phosphorus, arsenic, antimony and bismuth. There is a newly named element, that is moscovium. Moscovium is a synthetic radioactive element. Its property, it has got a very short half-life and only small amount only is available. So its properties are not established. The first two elements, nitrogen and phosphorus, are non-metals. Arsenic and antimony are metalloids. Bismuth is metal. Nitrogen exists as a gas and all the other elements are solids. Now let us explain the general properties of these elements. How the properties vary down the group. Down the group in group 15, atomic and ionic size. We know atomic and ionic size down the group increases. Nitrogen the smallest and bismuth and moscovium is the largest. If you compare the ionization enthalpy, delta Hi, down the group, we know that ionization enthalpy down the group decreases. Because as the size increases, nuclear attraction decreases, so easier to remove the electron from the valence shell. So ionization enthalpy down the group decreases. Nitrogen having maximum ionization enthalpy. When we compare the ionization enthalpy of group 15 with that of group 14 elements, that is carbon family, we see that ionization enthalpy of group 15 is higher than that of group 14. This is due to the extra stability of NS2-NP3 electronic configuration. Removal of one electron from this configuration will disturb the stability. Hence, more energy is needed to remove an electron from group 15 element. It has higher ionization enthalpy. Then electronegativity. Electronegativity down the group, we know electronegativity decreases. Nitrogen the highest electronegative. Then we have the next property, the metallic character. If you compare the metallic character, this is very clear from this one. First two elements are non-metal, the other two elements are metalloids, the last members are metal. That means metallic character down the group increases, or non-metallic character down the group decreases. All the elements of group 15, all elements show allotropy except nitrogen. Note that in group 15, the element which does not show allotropy, no allotropy, is shown by nitrogen atom. Nitrogen atom does not show allotropy. All the other elements from phosphorus onwards show allotropy. Now let us discuss about the oxidation state. Oxidation state of group 15 element. The electronic configuration we have already written. So we can easily find the oxidation state of group 15 element. The common oxidation state, it has got the electronic configuration we have already written, NS2 NP3. This is the configuration. If the group 15 element gain 3 electrons, because it contains 5 valence electrons, it has strong tendency to gain 3 more electrons to become stable. So if it gain 3 electron, it would show an oxidation state of -3. If the p electrons, only p electrons are removed during reaction, its oxidation state will be +3. If all the 5 electrons are removed, that is p electron and 2 s electrons are removed, it would show oxidation state +5. Now let us compare the stability of these oxidation state, stability of oxidation state down the group. If you take -3 oxidation state, -3 oxidation state, then +3, then +5. If you take the stability of -3 oxidation state down the group we know size increases, electronegativity decreases. So the ability to gain electron down the group decreases actually. So -3 oxidation state stability decreases down the group. If you take +3 and +5 oxidation state stability, +5 oxidation state is shown if along with the p electron, the ns electrons also removed. Down the group, when we come to the heavier elements of the group, that is from arsenic onwards, there comes a factor of d and f electron. D10 and F14 electrons are present between the nucleus and the outer NS2NP3 electron. These D10 and F14 electron, D and F electrons have very poor shielding effect. Because of poor shielding effect, these electrons experience more attraction from the nucleus, especially the NS electron. NS electrons are more attracted to the nucleus than the p electron. So ns electrons are not easily removed. When we come to the heavier elements of the group, ns electrons are not removed. Only the p electrons are removed. That means stability of +5 oxidation state down the group decreases. At the same time, stability of +3 oxidation state increases. This reluctance of s electron, valential s electrons not to take part in bonding is called inert pair effect. Because of poor shielding of d and f electron, ns electrons remain inert. This is called inert pair effect. Valence shell s electrons are not involved in bonding. They remain inert. Why are they inert? Because they are more attracted to the nucleus. Why? Because of the poor shielding effect of D10 and F14 electron. So down the group, stability of +3 state increases, +5 state decreases due to inert pair effect. The last member bismuth. Last member bismuth does not show a compound with a +5 oxidation state. The only stable compound or only non-compound of bismuth with the +5 oxidation state is bismuth pentafluoride. Note down, the only stable compound of bismuth with the +5 oxidation state is bismuth pentafluoride. Now let us discuss about the first member, the anomalous behavior of first member, that is nitrogen. Nitrogen, the first member, it has small size, highest electronegativity, highest ionization enthalpy, and its electronic configuration is 2s2 2p3. It contains 1 s atomic orbital and 3 p atomic orbital, s orbital with 2 electron, p orbital with 3 electron. It contains only 4 atomic orbitals. Only 4 atomic orbitals are present in nitrogen. No d atomic orbital. D atomic orbitals are absent in nitrogen. These properties make the chemistry of nitrogen different from other members of the group. Because it contains only 4 atomic orbitals in the valence shell for bonding, nitrogen can form maximum 4 covalent bonds. around it. Means around nitrogen we can find 4 covalent bonds only. That is, maximum covalency of nitrogen atom is limited to 4. All the other members, phosphorus onwards, covalency can be beyond 4 because they contain d atomic orbitals. More orbitals are available for bonding, but nitrogen only 4 atomic orbital. Maximum covalency of nitrogen atom in any compound will be 4. More than 4 is not possible. The another anomalous behavior of nitrogen is nitrogen being smallest size can form effective overlapping, sidewise overlapping with a p atomic orbital, resulting in the formation of pi bond. That is, nitrogen can form p pi bond. Nitrogen can form multiple bond. That is, nitrogen can form double bond to nitrogen. It can form triple bond to nitrogen. It can also form double bond to oxygen. It can form double bond to carbon. It can form triple bond to carbon. This is because of p pi overlapping. But the other members, phosphorus, arsenic, antimony onwards, the other heavier members cannot undergo p pi overlapping because their p atomic orbitals are large and diffuse, cannot undergo effective overlapping. So only nitrogen can form p pi overlapping. The other members of group 15 can undergo, instead of p pi, they can form p d bond. They can also form d pi bond. These bonding is possible only in the case of the other members, that is phosphorus, arsenic onwards. Nitrogen can form, only nitrogen can form p pi bond, which is not possible in the case of heavier members. Heavier members can form these two bonding. These two bonding will be present in heavier members of nitrogen family. If you compare the single bond strength between the nitrogen atom, nitrogen single bond, if you compare with the phosphorus single bond, if you compare bond strength of the single bond between nitrogen and between phosphorus, we see that this bond between the nitrogen single bond is weaker than the pp bond. This is stronger. Weaker bond between the single bond between nitrogen atom. Nitrogen single bond is weaker than phosphorus single bond. This is due to small size. There would be non-bonding electron, lone pair electron present in these elements. Here also there would be non-bonding electron. Nitrogen, because of small size, the repulsion between these non-bonding electrons will be much closer, and there will be more repulsion between the non-bonding electron. In the case of nitrogen, because of more repulsion, the bond is weaker. Because of this property, nitrogen does not show catenation tendency, or catenation tendency is weaker in the case of nitrogen. But all the other elements, phosphorus, arsenic, antimony, bismuth, all these elements show catenation. In nitrogen, the catenation tendency is very weak due to weak single bond between nitrogen atom.